Hello, Sir Yosef and everyone. In these opportunities, me and my group would like to present about our paper project for the LCA subject with the title Mass and Energy Flow Analysis of Soy Sauce Production. First, allow me to introduce you to our group member. And in this group, which is group 4, we have Brillian Maulani Putri, Ignatius David Fernando, dan Gilchrist Paraya, Miftakhul Syafina, Prastya Agung Supratman, and me, Visakha Nanda Wijaya. And before we go into the core materials of our presentation, I would like to give you an overview about our project. So, what are we doing in this project? We are trying to analyze and assess the sustainability of the soy sauce production system in East Java by adopting a life cycle approach using mass flow analysis. And this involves examining the energy and material flows throughout the entire production process, from raw soybeans to the finished packaged product, and identifying environmental impacts, particularly waste management challenges. And what is the purpose of this study? The purpose of this study is to assess the environmental impact of the soy sauce production process and provide practical recommendations to enhance sustainability. This includes improving resource management efficiency or optimizing resources, reducing waste, and identifying sustainable opportunities that we can apply to the existing system, such as recycling okara, treating wastewater for reuse, and adopting renewable energy system. And the motivation for this research stems from the growing importance of sustainability in industrial practices, particularly in developing countries like Indonesia. The soy sauce industry, being culturally and economically significant, faces challenges in efficient resource use and waste management. So, by addressing these challenges, we aim to contribute to achieving Indonesia's sustainability goals and global environmental objectives. And next part will be explained by my friend. Thank you.
Hello everyone, my name is Gilchrist, Paraya, and for now, I want to explain about the next slide, which is the methodology. First, the purpose of this study is first to evaluate sustainability, including environmental implication, and then utilize material flow analysis or MFA to measure input-output materials. So the purpose of this study is to evaluate the sustainability of soy sauce production, especially in terms of its environmental implication. We use material flow analysis or MFA, which is a method to measure the input and output of materials and to analyze their pathways and transformation within the production system. And next, number two, the goal and scope. The goal and scope, we use gate to gate model and then raw material to finished product. The main goal is to assess the sustainability of soy sauce production by systematically analyzing energy and material flows. This is done using a gate to gate approach, focusing solely on the production process. And for the scope of this study covers the entire production process from the raw soybeans to the final packaged soy sauce product. The data source, we collect the data from a soy sauce company located in Java, yes. And for number T, the functional unit, our analysis is based on one bottle of marketable soy sauce. This bottle serves as the functional unit to ensure consistent measurement of material and energy flows. And for number 4, As you can see, this is the system boundary. This boundary this boundary ensure that every material and energy flow from the beginning to the end of the production process is accounted for in our analysis. And this is also our system boundary. As you can see, the raw material, the main material, which is the raw soybeans, till it be the packaged soy sauce.
Inside the methodology, we use the material flow analysis methods to determine how the system boundary inside the soy sauce production itself. Inside the soy sauce production itself, we start from raw beans and ends up with actual packaged soy sauce. Inside the system boundary itself, there are nine processes, which is soaking, boiling, mixing, incubation, lactic fermentation, ripening, pressing, pasteurization, and lastly packaging. Inside the system boundary, there are to be noted some waste that are produced inside this production system. The waste itself are really important to note, and there are two types mostly, which is the chemical wastewater and wastewater, which is in the form of liquid waste, and lastly there are waste in the form of solid, which is solid waste, and also there are side product, which is the okara itself. And yeah, this system boundary methodology is crucial into figuring out what's the identification and environmental impact itself on the soy sauce production.
Hello, my name is Ignatius Fernando from Environmental Engineering Batch 2022. The next slide is identification and environmental impact of soy sauce productions. The soy sauce production process generates both liquid and solid waste at each stage. Liquid waste from sucking, boiling, fermentation, and filtration is rich in organic materials, salt, and acids, contributing to high biological oxygen demand or BOD and chemical oxygen demand or COD levels, which can harm aquatic ecosystem if untreated. Solid waste like okara or soybean pulp often remains unutilized and might contribute to pollutions. Proper waste management through wastewater treatment or WWTP and recycling initiative, such as using okara for animal feed or for fertilizer, can mitigate these impacts. Environmental concerns are heightened in small and medium-sized industries due to inadequate waste management practice.
Okay, for the next, our result is improvement opportunities and eco-friendly practices. Actually, there are so many improvement opportunities and eco-friendly practices, but uh, we try to give some improvement opportunities and eco-friendly practices that still relate with soy sauce production. To reduce the environmental footprint, soy sauce production can adopt innovative waste management practices. For example, a recycling system for water and energy, such as reusing boiling water for soaking and implementing biofilter or anaerobic treatment. It can be minimize wastewater and generate biogas as alternative energy. For the solid waste, including okara, can be repurposed as animal feed or fertilizer because it can be adding economic value. And switching to eco-friendly packaging materials like Maybe we can use biodegradable plastic or recycled glass, and improving the energy efficiency through renewable sources like solar panels or biomass further enhance the sustainability. These measures align with zero waste principles and eco-efficiency, and can be lowering pollution and operational costs.
And lastly, for the results and discussion, we'll talk about sustainability indicators and also recommendations. To monitor environmental performance, industry can track resources efficiency like water, energy usage per ton of soy sauce. Waste management compliance like BOD and the COD and also the pH and greenhouse gas emission. Adopting eco-friendly technologies such as activated sludge for wastewater treatment and setting measurable goals like a 10% uh, waste reduction target can also drive continuous improvement. Companies should educate employees about sustainability, collaborate with waste management firms, and explore innovative uses for waste product to enhance environmental responsibility while maintaining competitiveness in the market. And the next one is conclusion.
Hello everyone. In here I want to explain about conclusion. In this study has been able to approach and analyze the sustainable aspect of soy sauce production in East Java by applying a life cycle approach and using mass flow analysis method to analyze the flow of the process that are influenced in the industry. The material analysis flow method was used to analyze the environmental impact, determine the environmental sustainability indicator, and also the proposed recommendation to help increase efficiency and to improve sustainability. The big factor of the environmental impact are found in the production of soy sauce in the form of waste, more specifically liquid and solid waste. This waste is managed correctly, for example, reusing and recycling the liquid wastewater, which reduce production costs, improving efficiency and increasing sustainability. Thank you.
That's all from us. We're from Environmental Engineering, President University. My name is Prastya.
My name is Visakha.
My name is David.
My name is Brillian. My name is Tina.
And my name is Paraya. Thank you for watching and
See you!